Hi, welcome to my presentation, and the one hosting this presentation is me, Taruna Kugan, our intern, and my matrix number is AA190829. I am from section for computer architecture course. We will be presenting here about the set A question. The task is that I must change a code in C programming language to an assembly language, and in this video I am going to explain you guys about this. As we all know, assembly language is a low level language when we compare to C, which is a high level language. I must use the RIC simulator to run this assembly language, which is a simplified version and reduced version of complex instruction that we can see in world nowadays. Below down is the C code which I was required to change. This is the proposed instruction set that I proposed. The assembly language has also its own syntax, which is consist of label, opcode, operands and commands. Label and commands are optional, while the opcode and operands are compulsory. Before moving to the RIC simulator, come we see about the instruction set that I built to run in this simulator. This is the instruction set that I built. I'll give a brief explanation of what is in my instruction set. In the first line, which is INPR02, which means to receive an input from the user, where the user will enter the input from the keyboard and stores the results in register R0. In the second line, which is INPR12, the second input is required from the user and saving the value that the user enter in register R1. The 2 in the behind is the syntax of RI simulator input. The same process will repeat on line 3 INPR22, but in this line this time saving the value in register R2. The following line add R3, R1, R0, where we can see this add opcode, which commands to add the two values previously stored in R0 and R1 and saving the new result in register R3. We are saving the registers new values in the new registers. Here we can see, right, we need to save the results, if not the value will be forgotten. The fifth line comprises of the opcode sub that commands to subtract the value in R3 with the third input number R2 and in orderly storing them in register R4. In the sixth line, the instruction is out R44, which is to output the value stored in R4. The HLT halt in the last line obviously terminate the program. The algorithm of this problem is to take three integers num_a, num_b, num_c, adding the first two integers num_a plus num_b and subtracting the result of these integers with the third integer num_c, as well as storing these integers in the variable sum. The process starts from the first line, so we are going to hit the run button now. I'll slow the speed operation. Okay. The program starts at the first line INPR02. The program counter will get incremented by 1 and now points to the first location of memory. And at the same time, the address of the instruction is fetched from main memory through the B bus. The instruction is now loaded into the control unit instruction register. So the instruction register decode and transfer the control to the control unit. So the CU now executes the instruction. The INP shows that the instruction is to input a value from the keyboard by the user and this instruction is performed. I enter the value 5 in the keyboard place. The value will be transferred using the B bus and stored in the R0 register. Here is the second line of code. INPR12 is executed, so the address of the next instruction that the PC was pointing to is fetched and in the following order PC gets incremented and now it is pointing to the succeeding location of memory. The fetched instruction is passed to the B bus and loaded into the instruction register to be decoded. IR transfer the control to the CU and CU requires the user to enter the second input by executing this instruction. So in this case, I'll enter the value 5. The value is stored in the register R2, R1. As soon as operation finish, the value will be stored in the R1. I'll speed up the operation, guys. So The PC gets incremented and now it will become 3 and holds the address of the next location in RAM. The instruction 28962, it fetched from the memory location 2 and now it is fetched and transferred to the I instruction register using the B bus. The instruction register will decode this instruction and control is then passed to the CU to execute the instruction, which is to demand the user for the next input. And in this case, I'm pressing the number 2. This number 2 will get stored in the place R2. Based on the fourth line of code in assembly language, the processor proceeds to the next instruction that the PC is pointing to. And as the instruction is being fetched, the PC will be incrementing by 1. The instruction is loaded into the instruction register to be decoded. And the CU performs the operation. This time, CU shifts the operation to arithmetic and logic unit to perform the necessary operation, which is adding the first two values stored in register R0 and R1. The value of register R0 comes from A bus and the value of R1 comes from the B bus. The result is now will be stored in the register R3. The fetch cycle is repeated now. So the PC increments by 1 and pointing to the next location in memory. The address 25370 from address 4 is fetched and loaded into instruction register to be decoded, as well as the operation will be performed by CU. CU comes in action to execute the instruction and provides this operation to ALU to subtract the values of registers R3 and R2, and this value will be stored in register R4. Again, the fetch cycle is performed. Here, after fetching, loading, and decoding the instruction in instruction register, the CU now will perform the instruction, which is to display the value stored in R4 to the output box. Then, as usual, we proceed to the next instruction. PC gets incremented and is by 7. As the instruction is 0, it will be loaded into the main instruction register, and instruction 0 means halt this program. Yes guys, this is how to convert the code from C programming language to assembly language. I hope you can get a clear understanding of this RIC simulator. Thank you for joining us today.